Hello, and today we're going to find the partial fraction decomposition of a function when the degree of the numerator is greater than the degree of the denominator. Alright, so normally when we do partial fraction decompositions, the degree of the denominator is greater than the numerator. But what do we do when the numerator's degree is greater than the denominator? So what we're going to do is we're going to do long division. So I'm going to take the numerator, which is x cubed, plus 3x squared, plus 11x, plus 4, and like I said, we're going to do long division. So take x squared plus x. So it's basically like any other division you would do, like 4 and 24. So all we're going to do, how many times is 4? Actually, this is not a really good problem to do, because it goes in that 0 times. So yeah, it's just 6. That's not a really good problem to do. I don't know why I chose that one. Either way, though, first we need to figure out how many times does x squared go into x cubed. Well, x squared, or not plus, what am I doing? X squared times x equals x cubed, which means that x squared goes into x cubed x amount of times. So now, just like we would do with regular numbers, we're going to take x times x squared, which means we get x cubed, and then x times x, and we get x squared, because we can't forget about this one right here. So now we're going to actually subtract them. We're not going to add them, just like you would do with numbers in long division. You always want to think of it like that. So x cubed minus x cubed, that's going to be 0, plus, well, I guess it doesn't really matter because it's 0, but I like to write it anyways. We're going to get 3x squared minus x squared, so we can think about a 1 in front of that x squared, which means we get 2x squared. Now we're going to drop down these two values, so we get plus 11x and also 4. So now what we're going to do is we're going to figure out how many times x squared goes into 2x squared, and it goes in there 2 times. So 2 times x squared is 2x squared, and then 2 times x is 2x. So we subtract these, we get 0, and here we get 9x, drop down the 4, plus 4. So right now we have 3 numbers that we have. We have this one right here, this one right here, and this one right here. So what do we do with those numbers? Now, this number right here is going to be written first. We're going to have x plus 2. Now we're going to write these two as a fraction. So we're going to have fraction, we're going to have 9x plus 4 over x squared plus x. Now, this already took a lot of work, so you might think, oh, this is the end, this is our answer. We have f of x equals this. We did condense a little, but this is not the true partial fraction decomposition, because now we need to take this and decompress it. So we have 9x plus 4 over x squared plus x. So just like before, our first step is to see if we can factor this bottom one. So I can pull out an x, so we'll get x times x plus 1. So because there's no squareds here, or like non-factorable quadratics, irreducible quadratics, we can just write these two values in the denominator, x and x plus 1. And then on the top, we can do as normal. We can write a and b. And now we can just solve it like you would do with any other partial fraction decomposition. So we multiply the entire thing by x and x plus 1. So this side will just be 9x plus 4. Here we'll have a times x plus 1 And on this side, we'll have b times x. So to find our first value, I could just plug in -1 for x. So we get 9 times -1 plus 4 equals, this all cancels out, -b. So we get -9 plus 4, which is -5, equals -b, which means b equals 5. And now, what we can do is we can plug in x for 0, because this will equal 0. So we get 9 times 0, which is going to be 0, so we get 4 equals 0 plus 1 is 1, so we get 1 times a, which is just a, so 4 equals a. So we get b equals 5 and 4 equals a. So I'll write that up here. b equals 5, and then a equals 4. So our final answer is going to be f of x equals x plus 2 plus 5 over x plus 1 plus 4 over x. And this is going to be our true partial fraction decomposition.